So let us see, for example, if we have a problem like this, and I want to find the current. I want to find this current here. Current in the circuit, this current. How do you find the current? Okay, assume that now we have a voltage across this resistor. So we have a voltage, let's call it this VD, for example. Okay, VD. Oh, sorry for that. Okay, so this is the voltage across this diode is this VD. Okay, so in the first one, this VD is 0. You don't have a voltage. Then in this case, the current equal what? Equal 12 divided by 2K, the resistance. The voltage divided by the resistance. It is as simple as that. So this 12 volt divided by the resistance, this will give you the current. Here it is. Okay, because you don't have voltage dropped on the diode. In the second model, which is this one here, we assume that the voltage across the diode is, for example, VF. VF here is 0.7 because this is a silicon diode. Then the voltage across the resistor will not be 12 volt, will be 12 minus the voltage dropped on the diode. So it will be E, which is 12 volt, minus VD, which is 0.7. So it will be 12 minus 0.7. This is the voltage across the diode, across the resistor. The source is 12 minus the voltage across the diode, which is 0.7. Okay, so this is the voltage across the resistor. And when you divide it over the resistance, this will give you the current. The second model here is what? That you have, if you want to calculate the current in the resistor, then you need this voltage here. Okay? Or you have a resistance here, this R. Okay? This R bulk. This R bulk. So you have to consider the resistance also. Okay. In the second one, you don't have a resistance. R bulk is not considered. But in the third one here, you have to consider this R bulk. Okay, then in this case, the voltage across the resistance here, the total voltage here is 12 minus 0.7. Okay, and the total resistance is what? Is 2K, and the total resistance, the resistance of the diode is 10. Then this is the total resistance. So the voltage here is 12 minus 0.7, and the resistance is 2K plus 10. Okay, when you look at the difference here, I really do not see big difference. That's why we do not care too much about the third one. It's complicated, little complicated, but the difference is very trivial. So usually we use this model here. Okay. Second example, assume that we want to also use the same models used to solve this current, to find this current I, the current here I. So what we have here, we have this 9 volt is dropped over what? How many? 1, 2, 3, 4. You have 4 elements here. We have 2 resistors and 2 diodes, and all of them, the 2 diodes are forward because the positive is connected to positive. Okay, so now the total voltage across the 2 resistors equal what? Equal 9 volt minus the total voltage, the voltages across the 2 diodes. So VD1 plus VD2, VD1 and minus VD2, or plus. You can make it plus. So this is the total voltage here, the source voltage, and this is the voltage across the 2 diodes, VD1 and VD2. In the first approximation, this one here, you do not have a voltage across the diode. So VD1 and VD2 are 0. Okay, so that's why the current equal what? Equal 9 divided by 1K plus 2K, which is 3K. So it will be 9 divided by 3K. In the second model, we assume that the voltage across these diodes are considered 0.7. So we have a 0.7 here and 0.7 in the other one. So VD1 and VD2 are 0.7 and 0.7. So in this case, the voltage will be 9 volt minus 1.4 volt, 0.7 and 0.7. Okay, and this will be the current here divided by the total resistance, which is 1K plus 3K plus 2K, which is 3K. Of course, you can see a big difference here between 3 and 2.5. It's considerable difference. For model number 3, we have to consider the resistance of the two resistors. So in this case, the voltage will be the same, 9 volt minus 0.7 and 0.7 or 1.4, but the resistance will not be 3K. It will be 3K plus the resistance of the two diodes, 10 and 10. Our bulk here is 10. Where's our bulk? Our bulk is 10. Here it is. Okay, so this 10 for each, then it will be 20. So it will be 3K plus 20. Then the result will be this number here. Of course, as I said, when you compare these two here, they are very close to each other. That's why usually we assume that we use the model number 2. 2.53 and 2.5166, which is almost 2.52. The difference is not huge. Let us see another example. Assume that we have a circuit like this. Now we have a current here. The current is moving like this. Okay, and this diode is forward bias. It's forward bias because the positive is connected to the positive. Okay, so in this case, we have a voltage across this diode. The voltage across this diode. So now, if I want to find this current I, this current I equal what? Equal the voltage, the source voltage here, minus the voltage here. This called this VD. So the voltage at this node is VD. The voltage across this node here is, at this node is 10. So it is 10 minus VD divided by 1K. So this current equal 10 minus this VD divided by 1K. Okay. So now if we assume that we have the normal or the ideal case, then we do not have VD. VD is just 0. Then it will be 10. The current is 10 divided by the resistance, which is 1K. That's 10 milliampere. If we assume that we have a constant voltage here, we do not have a resistance, second model, then we have to put VD equal 0.7. Then 10 minus 0.7 divided by 1K, that is 9.3 milliampere. Okay, this is the current. Third, we have to consider the resistance of the diode. Okay, the voltage is 0.7 volt. VD is 0.7 volt. But we have to consider the resistance of the diodes. Okay, so what is this RT here? Don't know. Let me think about it. Okay, what's RT? RT in this case is what? This circuit will be as if you have a resistor like this, and you have a diode and the resistor. This is 1K also, and this is 1K. As a diode is considered a resistance that is 10 ohm. Okay, so now the current equal what? This current I, okay, equal this 10 volt minus 0.7 divided by the total resistance here. This total resistance. It will be 1K and 10 parallel with 1K. So this is the total resistance here. 1K parallel with 10, of course, you just multiply over the summation. You know, if you have two resistors in parallel, then 10 times 10K, times 1K, 10 times 1000 over 10 plus 1000. Then the resistance will be like this, 10 times 1000 divided by 10 plus 1000, which is 1010. So this is the resistance. Okay, this is the resistance. What's this? Okay, no, again, no, yeah, this is a parallel here, parallel connection. Then you add this to 1K. So this is 1K parallel with 10. Then you add 1000. Then this is the resistance. It is 1009.9 ohm. Then the voltage here is 10 volt minus 0.7 dropped on the diode, then this is the voltage divided by the total resistance. This will give you the current, which is 9.2 milliampere. As you see, also you compare these two numbers, they are almost the same. That's why it's not worth saying that you do it using this model. If you want to do this using P2Spice, you can do it using P2Spice. You can just the same example. This is 1K and this is 1K. Okay, and if you want to calculate, for example, here the voltage across this resistor here and the current here, you can make this circuit here in P2Spice and then calculate the voltage to make this figure here to see how it look like the relation between voltage and current. Okay, so this is the, of course, Vm here. This is the voltage across the diode, and this is the current in the diode. This is the current in the diode. So this is a little bit different from the previous problem because we calculate the current in the diode, not in the circuit, not the source. But here shows the curve, the voltage current relation of the diode. So as you see here, it is very small current, and then after that, after 711 millivolt, the current start to increase rapidly like this. Let us see this example. So as you see here, I just neglected the third model. I just used this model, which is model number 2. We have this circuit here, and we need to calculate the voltages, the diode voltage. So we need to calculate this voltage here, VD2, positive, negative, and VD1. Maybe we need VD1. Do we need VD1? I don't know. And we need the voltage across the resistor. The voltage across the resistor is the same. So this VR or V2K, I call it here V2K, is the same like VD2. There's no difference because they are parallel to each other. Okay, and I want to calculate this current. So how do I calculate the current? The current equals this voltage, which is 20 volt. Okay, minus this voltage, sorry, divided by 1K. This is how you calculate the current. Okay, but let's see here how we do this. But of course here you can't do that. Let's see. First you can say this voltage here is what? What's this voltage? This is actually not forward bias. So this is actually reverse bias. So this one is reversed. So since this one is reverse, D2 is acting as open circuit. D2 is acting as open circuit. So we can redraw the circuit like this. We can say, okay, this one here, and you have D1. D1 is forward bias. And you have a voltage across, okay, come on here, positive, negative. This one is 20 volt. And you have this 2K, and this one K. Okay. So now you have you don't have D2 because, as I said, the second diode is reverse bias. Okay, so it is open circuit. Since it's open circuit, you can remove it. And now, what is the current? I equal what? I equal the total resistance, total voltage here divided by the total resistance. The total voltage is what? You have 20 volt, and 0.7 of them is dropped on the diode. So 0.7 volt is dropped on the diode. We have this 20 volt dropped on what? Dropped on the 1K and the 0.7 and the 2K. So 3. Okay. I know that the diode is 0.7. Okay. So now the voltage dropped on the 1K and the 2K is what? Is 20 minus 0.7. So here is the voltage across the two resistors. 20 volt minus 0.7, which is dropped over D1. Divided by the total resistance, which is 1K plus 2K. That's 3K. So now we can calculate the current. We can calculate I. Once you know I, of course, you can use Ohm's law to calculate the voltage across the 1K. So current time 1K. That's it. Point current, the current time 1K. And also, if you want to calculate the voltage across the 2K, it is the same current. The current did not change because the current here, this current I, will continue in this resistor here because you do not have a current in the second diode because it is open circuit. So this is still I. That's why when we draw it like this, the same current. This is the same I. So the voltage across the 2K is I times this 2K. I times this 2K. And of course, the voltage across the diode, the second diode, will be the same like the voltage across the second resistor. It is the same. There is no difference.